Scientists have finally discovered the reason behind the strange shape of the center of the Andromeda Galaxy after years of research. This unusual shape is the result of a phenomenon known as gravitational kick. An odd star cluster is located at the center of the Andromeda Galaxy, which is 2.5 million light-years away and is the closest neighbor to the Milky Way. This peculiar shape had puzzled scientists for years. However, new research on how galaxies collide and the supermassive black holes at their centers has provided an explanation for this strange cluster. It appears that the formation of this cluster is due to a gravitational kick, a process akin to a gun's kick but on a cosmic scale. According to a new study, this kick was powerful enough to create a stretched cluster of millions of stars instead of a symmetric star cluster, which is typically found at the center of galaxies like Andromeda. Tatsuya Akiba, an astrophysicist at the University of Colorado Boulder, stated, "When galaxies merge, their supermassive black holes also merge to eventually become one black hole." Now we want to understand what the consequences of this event are. Researchers conducted computer simulations of supermassive black hole collisions to determine the cause of this phenomenon. The resulting force was sufficient to stretch the orbits of stars close to the galaxy. After the galaxies collided, their supermassive black holes began orbiting each other, and their speed increased prior to the collision. This process releases large amounts of energy in the form of gravitational wave pulses. Gravitational waves are fluctuations in the fabric of spacetime. Although the waves generated by these merges do not directly affect the stars in the galaxy, they can influence their positions. According to the models, a strong jolt might be delivered in a particular direction to the supermassive black hole. If this jolt is not too strong or very weak, it can only lead to the ejection of a collection of stars. Akiba noted, gravitational waves carry momentum from the remaining black hole, creating a kick similar to a gun's kick. Some supermassive black holes can move at very high speeds, allowing them to escape from their host galaxies. Conversely, black holes that lack sufficient velocity can still leave behind a stretched cluster of stars in an off-center nuclear disk. It is estimated that there are 2 trillion galaxies in the universe, and not all galaxies follow the same pattern. Researchers believe their project can help describe the diversity of star clusters outside of Andromeda and the Milky Way. The next step in this type of analysis involves scaling models from hundreds of stars to millions of stars and potentially implementing simulation methods for various types of galaxies. And Marie Madigan stated that the idea of being in orbit around a central object that suddenly escapes can be generalized to many different systems. For centuries, astronomers viewed the Andromeda Galaxy as part of the Milky Way, considering it a spiral nebula resembling other bright gas masses in our galaxy. As a result, it was initially named the Andromeda Nebula, and this name became commonly accepted. In 1864, William Huggins examined Andromeda's spectrum and compared it to that of a gas nebula, theorizing that Andromeda is a single star, leading to the inference that it has a stellar nature. Scientists have indicated the existence of an exoplanet within the Andromeda Galaxy using the microlensing phenomenon PA99-2, which has a mass 6.34 times that of Jupiter. If the existence of this planet is confirmed in future studies, it will be the first exoplanet discovered outside of the Milky Way. Thus, we now know for sure that the Andromeda Galaxy, and likely all other galaxies in the universe, have their own planets. But does life exist in the Andromeda Galaxy? Investigating the presence of life in the Andromeda Galaxy will be extremely challenging. Our most powerful tool for detecting signs of extraterrestrial life, the James Webb Space Telescope, does not have the capability to examine potential signs of life on planets in Andromeda. Another complication arises from the fact that many unusual signals in the Andromeda Galaxy may stem from unique physical phenomena that we are still unfamiliar with. As a result, determining which observations indicate signs of life is not highly certain. It's also important to note that the light from this galaxy takes 2.5 billion years to reach us, so it's possible that signs of intelligent life have not yet reached the Milky Way and Earth.